Global Health Solutions present HeartQuest HRV as a functional assessment tools for research and education purpose only. So let's start and see how the heart rate variability is working. So first we record the electrical activity of the heart, we record the electrocardiogram, and then so computer will help us to calculate each RR intervals, which is showing up over here, so the HRV analysis. So we have three different calculations. So one of them is called time domain, second one is a frequency domain method, and the third one it's a non-linear method analysis. So let's go more in deep and see so what's the difference. So the first one, we record the electrocardiogram, we calculate RR interval, which is transferred into the arrhythmogram. So this is a time domain. So they're basically calculating RR interval and building the arrhythmogram. So in the arrhythmogram we see, so it's kind of like a waveform because the R wave is changing. When it's changing smoothly normally, so we see it's kind of like, well, waveform. So from this one, so we can see and calculate how much we have affecting different frequency spectrum. So this is what the second part of the analysis, the heart rate variability. It's they call frequency domain. We have very low frequency, and high frequencies. So how they calculate it? So through specific formula they call fast Fourier transform, or FFT, we calculate different frequency spectrum. It's like light going through the prism and we see a different color. The same kind of like idea, we see very low frequency, and high frequencies. So this is what they kind of like represent over here. So the low frequency is more represent sympathetic part of autonomic nervous system. High frequency is a parasympathetic one. And then so we can see how much percentage of this different frequency represent in this pie. In this case, so we see 50% high frequencies, 35% low frequencies. This is the sympathetic parts and this is the parasympathetic parts. And we see 15% of very low frequencies corresponding with this analysis. So why the difference? So the basically human frequency spectrum. Ideally, so we would like to see kind of like a relative states. So the balance between sympathetic and parasympathetic and neurohormonal regulation. With a different condition, so we see, so for example in this one, so we see it's a lot of low frequencies high, so it's correlating with a high sympathetic dominance. And this one, so we see it's a lot of high frequency predominance, so usually we see this is a parasympathetic predominance. In the younger adult or athletes with accompanying with a high vital force and low stress index, so it's showing up ability quickly to recover and increasing anabolism stage. But when we see this pattern with a low vital force and high stress, so this is kind of like well sign of early adrenal insufficiency. And then so predominant of the VLF, so it's well telling us so some neurohormonal regulation is taking over, and so limbic thalamic area will involve, and this why so it's kind of like we need to look a little bit more in deep into this area. So let's start and see what's the non-linear method. So basically it's a different kind of like well analysis. So we want to see how the heart rate is changing on a different perspective. So in this case, so we see, so it's kind of like well heart rate variation, and we see it's like shape of the distribution of the heart rate. It's kind of like an oval, or they call it cloud space. So this is the normal one. Let's see how they looks on the different condition. So this is the what's the kind of like a normal distribution. So autonomic index in the heart rate variability with normal limit. So we're in the green zone, and its shape of the scatterogram is looks like a cloud. Let's see of this one. So we have a two type of abnormal heartbeats, and how they looks on the scatterogram. One of them is over here, so they call tight cloud, and it's represent more with a sympathetic dominance. In this one, so it's kind of like cloud is very spread out, so it's kind of like a wide, and this is more with arrhythmia and with a high parasympathetic dominance. This is what the kind of like looks like scatterogram and the histogram. So histogram is moved more over to the sympathetic dominance, and we see so the cloud is more tight. This is another example of the tight cloud. So the histogram is kind of like small one, so we have 2 or 3 bars, and the cloud is kind of like moving to away from the normal. So this is kind of like, well, when we go lower one, so it will represent more sympathetic dominance. When we go above, it's more parasympathetics. So this is the timing. So this is 1 second. So between our interval, this is what the kind of like we see. So increasing sympathetic dominance, the heart rate is increasing. So this is what we we see. So it's a different kind of like arrhythmogram, and when we see it's a lot of like this pink lines, so it means so the computer trying to filtrate them. So this is the sign of the arrhythmia, especially when it's going up and down, up and down. So this why, so in some cases, so when we see like this, so we don't take in consideration these numbers, because all of this number will be over high, and this is kind of like will produce some false positive information. So when we see this one, so this will confirm it's have arrhythmia. This is how they looks on the histogram and the scatterogram. See, the scatterogram is so wide distributed, and the histogram is shifted over to more red zone. So this is how they looks like. Let's see how this is a different kind of like arrhythmia. So it's the histogram is again, so it's a little bit more wider, and the scatterogram is more wider, and the histogram is kind of like, well, not a normal shape like like a triangle, like a little pyramid. So it's kind of like, well, different shape. So this is what we see, the PVC. When we see, so the pink line is kind of like one small and one high, one small and one high, so we're suspicious for premature ventricular contraction. So when we click on this pink line, so it will move the electrocardiogram, and we can see, so this is an episode of the premature ventricular contraction. And this is during the recording, so how many times it was happening. So this is what how they looks like on the histogram and the scatterogram. So this red zone, so it's showing up where the PVC is producing, and then they're trying to take it out from the calculation. Another very important parameter, so when you see the warning, so it's a possible with a high numbers A, B, C, D, so it's a high possibility of some different abnormal heartbeats. So in this case, so we see it's early weakness of a sinoatrial node. So we see, so electrocardiogram, but the electrocardiogram looks on the first view it looks normal, but when you look on the arrhythmogram, you see it's kind of like, it's not a waveform, it's more kind of like up and down, up and down, up and down quickly. And this is kind of like early stage of the sinoatrial node insufficiency. This is how they looks like on the histogram and on a scatterogram. So, but we want to see what's the difference. So, especially with older people. So you see, so there's arrhythmogram, it looks like up and down, but they doesn't have a nice pattern for arrhythmogram. So it's more kind of like straight line, up and down, but if you will look at, so it's kind of like more straight line. So this is what they kind of like more suspicious for the SI node weakness. Sometimes we see this on the younger population. So this is what we see, it's in younger kids. So it's up and down, but we see so the same pattern, so it's going up and down, so basically it's a little waveform it's producing. So because it's called physiological arrhythmia, and especially when we see this in the younger population, younger kids. So that's why, so it's a difference between this one and this one. So you see the difference, so they have a little bit more waveform pattern instead of like this one is more kind of like straight line. It's another interesting finding. So this is atrioventricular block. So when you see like this, so you have to analyze electrocardiogram signals. So the first over here, so we see the P wave and then QRS complex. And then so it's appearing P wave and no QRS complex. And then a little later, so no P wave and the QRS complex. So the impulses from the SI node is not going through the atrioventricular and it's blocking. And especially when you see, so the heart rate is very, very low. In this case, so we see the heart rate is 38. So this is what's the sign of atrioventricular block. So sometimes it's going through, sometimes it's blocking. Sometimes it's no P wave, normal, no P wave, normal. So this is what we kind of like differentiate different rhythms of the heart rate. So this is kind of like quick review of different arrhythmia and different heart rhythm patterns.